So 7. You remember when they ask you, please find the difference between the largest value recorded and the smallest. So basically, you need to tell me which one of these is the largest number that was recorded or has an X. So which one of these has an X on it? That's the largest number. It's up here. Which one of these numbers is the biggest number that has an X? 12 and what? Not 12 and 1/4. 12 and 3/4. Good job. Okay. Which fraction up here is the smallest number that has an X?
Here.
Which one of these is the smallest number that has an X? You can have more than one X. Good job. And finding the difference is what kind of math? Perfect. Good job. Now, guys, based off of this, Hunter, head up. 12, you can sit down. Yeah, good job. 12 and 3/4 minus 12 and 1/8. Can I do that? Can I find the difference with those two fractions? Raise your hand if you think you can. Raise your hand if you think you cannot. If you're raising your hand, great job. If you didn't raise your hand at all, it's because you're probably not paying attention or you don't know. And if you don't know, come talk to me. Okay, 12 and 3/4 minus 12 and 1/8. What is our thing we must do if we cannot, if we don't have the same denominators with the accent? Dylan. Convert. Okay? Well, why 2? Why must you multiply the 4 by 2, Dylan? So, and what we multiply at the bottom, we multiply it to the. So, in my favorite color, 2 times 2. So what is the new fraction that I am subtracting 12 and 1/8 by? 6/8. Great job. So, I am very confident that you wonderful kids can solve this. Raise your hand if you know what 12 minus 12 is. Raise your hand if you know what 12 minus 12 is. Everybody should be raising their hand, even if they're bored, Hunter. Good job. What's 6 minus 1, class? Do I subtract denominators when I am subtracting or adding the change? So what's the difference on this line plot between the largest and the smallest? 5/8. That is a quiz question. Finding the difference between the largest amount and the smallest amount. Important. So, when you're asked that on your wonderful quiz on Friday, can I subtract 13 from 12 and 1/8? It's that how I would find the difference. Remember, to find the difference between the largest amount recorded and the smallest amount recorded, would I subtract anything from 13 on this line plot? Would I? No. Great job. And that is because there is nothing right there. Absolutely nothing. Good job. Good job. Okay. In order to earn your recess, you must have your whiteboard out right now. If you need to borrow a whiteboard or a whiteboard marker and return it, you can come here. Hey, I have to use the number return it. Go ahead. Thanks for letting me know about that. Thanks for sharing. What? One more math problem. Chill out. Okay. In order to, during your recess, in order to, call it an exit ticket if you will. Your ticket, your exit ticket to recess. Okay, I'll wait till I know you guys are listening and not. I'm waiting. Okay. I'm gonna have to solve another quiz problem. You're going to be given a line graph, whether you have to fill it in or it's provided for you. In this case, it's provided for you. The X's are already printed, made, shown. You must find the total sum of the length with the most recordings. That basically means which length has the most X's. Find the sum. What do I mean by that when I want you to find the sum? What kind of math is that? Find the sum. So we're going to add the length on here, the amount of times means the number of X's. That tells you the amount of times you have to add it. If you are looking at whiteboards, that tells you right away you do not know this. You need support. Come to see me at recess on Thursday. Find the sum, meaning which length on here, which length on this line plot has the most X's. You then find the sum and add it by how many X's there are. That's what that means. So I will do this much. I will do this much. I will let somebody tell me which length on this line plot is displaying the most recordings or most X's. Dylan. 12 and 1/4. 12 and 1/4. How many times am I going to add 12 and 1/4, Marco? If you can't see it from back there, it's okay. 1, 2, 3, 4. Give me the correct number. 12 and 1/4 plus 12 and 1/4 plus 12 and 1/4 plus 12 and 1/4 plus 12 and 1/4. If you know it, just write it down and flip it over. If you are looking at whiteboards to get the answers so you cannot avoid recess, you're not doing yourself a service. You need to come see me. So think about your choices. Joey, think about your choices. Joey? Now, I will suggest one thing. When we are working with larger whole numbers like 12, when we have to add it 1, 2, 3, 4, 5 times, would be a bad suggestion just to multiply it. Now, do not feel you have to convert this time. But I see people already doing it, put it down. But then that means you must show me the correct improper fractions, such as in row 1. How are we doing? Was row 1 100% done? How about row 2? Is that 100% done? Show me this side of the class. Show me on row 1. Show me. Yep. 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 Okay. Nope. Okay. If I said no to you, you're not adding correctly. 12 and 1 4. How many x's are there? So you need to add 12 and 1 4 5 times. This row right here. Nope. Yep. Yep. No. Row 3, if you are done. Head up. Nice job, man. Yep.
I got my answer.
Row 4, you are done.
Look it. Look it.
Nope. Check your whole number.
Am I right?
Check your whole number. No, check it. No, check your whole number and your numerator down. Remember, you're adding the sum. So, you're part of group 3, Landon.
I know. Am I right?
No. You're going to do this. Okay, guys. One of two things. Or those that are getting incorrect. Those that are like, I thought I did it right, Mr. Kimber. You're almost there.
Oh no.
Okay. One of two things. You can either multiply this times that. Marco, what's 12 times 5? Okay, you're not going to touch the denominator here. What's 5 times 1? Bang. Now we would convert this normally. How about this? Add 12 plus 12 plus 12 plus 12 plus 12, which is, okay. And then, Mason, what's 1 plus 1 plus 1 plus 1 plus 1? What's 1 5 times? Mason, when we add or subtract fractions, the denominator, do they change? And if you converted this to a proper